So first I want to discuss a couple of things we need. For example, the first trig identity is sine squared x plus cosine squared x equals 1. And then if you divide each term by sine squared x, you get 1 plus cotangent squared x equals cosecant squared x, because we are dividing by sine squared. Now when we divide by cosine squared, so sine squared over cosine squared will give me tangent squared x. Cosine squared over cosine squared is 1. And then 1 over cosine squared will be secant squared x, right? So these are all identities I need. And we will use one very powerful formula like this. If you have integration of a function, you have derivative in the top, and then the denominator has main function dx. Then with a quick u substitution, you can easily see that u equals f of x. Then our du will be f prime x dx. When I make the substitutions, it is 1 over u du. And this integral is known as natural log of u. And you can substitute back u equals fx. So you know this one. So we'll be using some examples now. Say integration, you have a 2x here, and you have 1 plus x squared dx. Since you know that the derivative of 1 plus x squared is 2x, so we can follow this formula here, and immediately I can say my integral is natural log of absolute value of 1 plus x squared. Since x is a real number, in this case 1 plus x squared is always positive. If we avoid the absolute value sign is fine, but I will say for simplicity keep absolute value sign. All right, so we get this one. So we'll take another couple of examples. So look at example number 2. You have 1 plus tan x in the denominator and secant squared x dx there. So if I consider 1 plus tan x as u, then I see secant squared dx is coming out as du. So the derivative of 1 plus tan x is secant squared. So that's why we can say that this integral is natural log of 1 plus tan x absolute value sign. Integral constant we always add. So this is another one. I'll take another powerful example. Let's take integral secant x. Okay, so secant x integral is not known. We'll do a small trick here. Secant x we have, then we multiply numerator denominator by secant x and tangent x. So I put that one here also. Secant x plus tangent x dx. Now if you look at the denominator of sec u equals secant x plus tangent x. When you take the derivative du dx, secant x gives me secant x tangent x plus tangent gives me secant squared x. Now you can easily see that du is, if I factor out secant x, I get tan x plus secant x dx. So you can clearly see that the denominator is in the top. So then what happens in this case, we can just say that my integral is natural log of secant x plus tangent x, right? So this is the integral. Very fast you can get it. Example 4, we are taking integration of tangent x. Also this is non-standard. We don't know exactly what was the function whose derivative is tan x. But this one can be written as this. Tan x equals sine x over cosine x. All right. So then the derivative of cosine is negative sine. We know that. So let me adjust this one right here. Negative sine x. And I put here cosine x dx. Now since I put a negative, I need to balance it here. Or you can go with u for cosine x. So then what happens now? Negative, the cosine x has derivative, negative sine x. So the answer will be natural log of cosine x. And since I have a negative, I can further adjust like this. And that's our integral.